All right, so this lab, guys, is going to be on making a position versus time graph with data that we gather. All right, now the we gather part is going to be, I'm going to have a couple of helpers up here, and we're going to just get some of the data using our incredibly groovy toy carts. Okay, so what we're going to do is we're actually going to attach a data cart, okay, which you'll use quite a bit more in physics, onto this using a MacGyvered hitch kind of thing that we tape on, okay? And it's just going to pull the cart along, and the cart records data 20 times per second. Okay, so it records its position 20 times every second as we pull it along. Right? We are going to run each trial for probably 2 seconds. Okay? So that will be the thing that we're establishing, okay, here. So we're going to run for 2 seconds, and we're going to record the position 20 times per second. Okay? Now, I want you to think about what our manipulated and responding variables are. Okay? I'm determining, as the experimenter, that the length of the experiment shall be 2 seconds. Okay? Every cart, I'm going to make sure, 2 seconds, because if I let some of the carts go for 10 seconds, they'll go a lot further. Okay? So, does the amount of time I let the cart travel for influence how far it goes? It does. So, spoiler alert, time is going on the x-axis, which is where which variable always goes? The manipulated variable. Manipulated variable always goes on the x-axis. I'm manipulating time by choosing the interval over which I record data. Okay, that's going to seem weird. And whenever it's the first time I'm telling people we're going to use time as a manipulated variable, they think we're like time traveling or doing some weird stuff. Okay, manipulation of time can be as simple as saying I'm only going to record for this long. Okay, if I record for longer, it'll go further. Okay, and that way the position of the cart may be responding to how long I let the cart travel for. Okay. Now, some things that need to stay the same. We're going to run 4 different carts. That's not the manipulated variable. We've already established what the manipulated variable is. Okay? During the 2 second time period, the speed of the cart is constant. Okay? These carts travel at constant velocities. Okay? That's important because I want to get a certain shape on my graph. Okay? If they accelerate, the graph will look like what? It'll look like a curve. We looked at that yesterday. I don't want that. Okay? I want a graph that's a nice straight line. So I need to make sure that the speed is controlled. Okay? Now, I need you to come up with 2 more controlled variables. You don't need to do it right now. You can watch how we carry out the experiment and figure out what 2 others are. There's more than 2, but you'll be able to get 2 others for sure, okay, when you watch how we do this. Okay, so kind of be watching for that as we carry out the experiment. Now, for our hypothesis, okay, we're going to have an if, and then statement, but it's going to be about objects that travel at a constant velocity, position versus time graphs, and calculating velocity. Okay, so the if part, okay, needs to talk about what it means to travel at a constant velocity. Okay, in terms of what your position does. I want you to think about what we looked at with those graphs yesterday, like the very first graph we did where we had that nice big diagonal line and we figured out how fast it was going because it did something every second that was the same. Okay? The and part, as always, describes the experiment. In this experiment, constant velocity carts are going to be allowed to travel along a piece of floor with their position and time recorded. That's all we're doing, recording the position and time for a cart traveling at a constant velocity. Okay, the then part. How will you calculate velocity from the position versus time graph? Okay. And in here, I'm thinking you should probably talk about this. Maybe a certain part of that formula represents the velocity of the cart, and you could mention how you might calculate that.
What was it for the add part?
You're just describing the experiment, so the carts are allowed to travel and we're recording their position and time. Okay, so for the experiment part, like I said, we're just gonna run the 4 carts up here, 2 seconds each, or as close to 2 seconds. I'll trim the data, okay? And what we're gonna do is, I'm gonna collect the data using my phone, okay? Because my phone has an app on it that talks to the cart, okay? And the cart will send the data to my phone, and I'll quickly make a Google Sheet and put it in Google Classroom with this experiment, okay? You'll have to make a copy of that, okay? Or copy and paste from it into your Google Sheet that's already in there, okay? So in yours, okay, if you look at the position versus time, you've got a Google Sheet here already. So what I'm gonna do is post another Google Sheet in here, but it'll be read only, okay, or view only. You'll just have to highlight the data, copy and paste it into your Google Sheet, and then we'll build the graph from there. Okay, so it'll take me a couple of minutes. While I'm doing that, you can continue to write the stuff to do with your variables and your hypothesis and get all of that done. Okay, everybody with me so far? Okay, so while we're doing this experiment, we want to watch for a few things. We want to watch for 2 more control variables. Okay, and we want to watch for any sources of error for later on in the experiment. Okay, for when we're doing our evaluation part. Okay, what are some possible sources of error? So, this is our rig. Okay, and anyone who's watching this later, there's actually an observations video that is me doing this during COVID. You can tell because I'm wearing my buff. And, so it's okay. So this is going to be our rig. I'm just going to tape the data cart to the motorized cart with this ruler. Okay, the ruler makes sure, as best I can, that all 4 wheels of the cart are actually on the ground and turning. If they're not, the cart will not record the data. Okay, so I just tape them together like this, and then I'm going to start this cart, okay, which, like I said, is motorized, so we'll pull it along. Okay, pull it along the floor for about 2 seconds, and then I'll put a different cart down. Okay, and we're going to do it with 4 different carts. Okay, now I could use a couple of helpers. Anybody want to volunteer to help me up here? I mean, I've done this by myself, but it's easier if I have help. All you're going to have to do is start the cart when I tell you, and stop the cart when I tell you. It's an easy job. Okay, thanks. All right, just so everyone can kind of follow along here with what you need to do with the data. Okay, I've cleaned up the data, right? So if you open up this Google Sheet, okay, which should be there now, you're going to get something like what we looked at the other day when we were building graphs with Google Sheets. Okay, so here's what we want to do. We want to build a scatter plot just like we did the other day, okay, with this data. So we've got the time, we've got the position for each of the 4 runs. Okay, so if we want to make a good graph of that, okay, we want to highlight everything down to 2 seconds. That's as long as I said we would run it for. Okay, and because this is view only, okay, here's what I want to do. I want to make a copy, or just copy this, so copy it, and then paste it in your own Google Sheet. So now I'm going to go to my Google Sheet that has my name on it. Okay, and I'm going to paste that data in. It's already highlighted for me because I just pasted it. So now I can go insert chart, and it's probably going to pick the wrong kind. It did, okay? So it picked a line chart, which I don't want, okay? The first time I did this, it picked a bar graph. It was a mess, okay? Remember, we want this to be a scatter plot. So we click here, and we go down to scatter, which now makes it dots, okay? Like we wanted from the other day, okay? And then we can go to customize, and we can put the stuff in, right? So we probably want to put in a better title. We need to label that axis. We need to take the run one probably off of this. Okay, so a few things to change in there. But the big thing is that for each one of those data sets, you need a trend line. So you click here. Okay, there's a trend line now drawn for each of them. And where it says label, click on that. Use equation, and now you've got y equals 0.31 times x plus this, okay, for run 2, 0.354 plus that number for, okay, and so you got the y equals m, so this number is m, that number is, well, x, and then that number is b, okay, so it's all in there, okay, and then you can get started on the analysis. All right, so I'll give everybody a couple minutes to get the graph kind of built, okay, if you need some help with that, call me over and I can give you a hand. Okay, and then we can talk about the analysis from there. Okay, and guys, once you have the chart, the graph built, okay, then I would like you to copy two things over into your lab report. Okay, the first thing is this data here. Okay, so for that you're going to want to just highlight it again, like you did the first time. Okay, and copy that into your Google Doc. And because it does ask for it here, copy and paste your Google Sheets table and graphs here. So okay, just go in there. Okay, so we'll put it in there, and it's going to run maybe a page. That's fine. Okay, and you also want to put in your graph. Okay, so that was. So to paste your graph or copy your graph, hit the 3 dots at the top, okay, copy the chart, and then go back to your Google Doc and put it in right underneath your data, right there. And it'll ask you link to spreadsheet. You want to do that. That way if you make any changes in the Google Sheet, it automatically updates the Google Doc. Okay, now you've got everything in there that you need to do the analysis. Recorded here. Okay, so in the analysis questions, you're asked to do 3 things. Okay, and question number 1 says, show how you would calculate the slope of each car's line on the graph. So it's asking you, show me the equation here so that it's m equals. Okay, so you're manipulating it for the slope. Okay, and so you're going to actually have numbers in here. Don't plug in numbers for y and x. Okay, so what I'm saying here is this. For question number 1, you have y equals, and I'm just going to make up numbers here, but let's say 0.358x plus negative 0.215. Okay, I want this manipulated so that it equals m. Okay, so if I had just y equals m times x plus b, okay, I would subtract b, divide by x. I want to see that. Just don't put numbers in for y and x. Okay, just bring them over as y and x. I just want to see the number that represents the slope, okay, isolated, right, with the appropriate units. Okay, think about what the units for the slope of this graph should be. Okay. For question number 2, using the equation, so using this equation for each car, okay, calculate how far each car would travel in 150 seconds. Show your work. So if you're doing it on paper, take a picture of it and insert the picture. Okay, or just type it in. It's not a ton of algebra, so you could probably just type it in just as easy. Totally up to you, whichever way works. Okay, so tell me how far it would travel, okay, in 150 seconds for each car. So you're going to have 4 of basically the same calculation with different equations. Okay, and then for question number 3, using the equations for each car, calculate how long it would take each car to travel 100 meters. Show your work. You might be able to go back to what we did on Friday, where I showed you exactly how to do that, and you did it as well, okay, using the sample data that I put on there. Okay, so if you remember on Friday, I said, this is going to be exactly what I'm going to ask you to do in your analysis. Okay, that's what I'm asking you to do. Okay, so you're solving for either y or x in question number 2 and question number 3. You just have to manipulate and solve. Okay, questions on that? So the analysis is all algebra. It's all plugging in the numbers and stuff like that. Okay, conclusion, same as always, copy and paste your hypothesis. Were you able to calculate the velocity? How did you do that? Okay, and then your 2 sources of error. Okay, so as you watch that, or if you didn't figure something out or you missed it, you can always go back and watch the video of me doing it, okay, in there. You don't have to watch all 4 trials. Okay, just watch one and that'll be enough for you to figure out what the sources of error might have been. Okay, questions on the expectations there? Okay, I made it due a week from today. Alright, so if you need some help, make sure you pop in and see me at nighttime or lunch or before school or after school, rest of the week.